Hi everyone, welcome back to the Coding Interview Must-Know series. Today, we're tackling a classic string problem, the longest common prefix. Here's the problem. You're given an array of strings, and your task is to find the longest prefix shared by all of them. If there's no common prefix, just return an empty string. For example, if the input is flower, flow, flight, the longest common prefix is FL. But if the input is dog, race car, car, there's no shared prefix, so we return an empty string. The first common approach is called the character-by-character scan. The idea is simple. Start from the first character of the first string and check that same position across all the other strings. If all of them match, move to the next character. But as soon as one character doesn't match, it means the common prefix ends at the previous position. The Python implementation is very straightforward. We loop through each character of the first string, and in every iteration, compare it with the character in the same position of all other strings. If we hit an out-of-range index or find a mismatch, we return the prefix we've built so far. If the loop completes with no issues, that means the entire first string is the common prefix. This method runs in OS time, where S is the total number of characters across all strings, and it uses O1 extra space. The second method is the sorting approach. If we sort all strings in lexicographical order, similar strings will be placed next to each other. The key insight is that the longest common prefix of the whole array must be the common prefix of the first and last strings after sorting. That's because those two are the most different in order. If they share a prefix, every string in between must share it too. Look at this example. After sorting, we get internal, internet, interview, interval. We only need to compare the first word internal and the last one interval. Their common prefix, inter, is the answer for the entire array. The Python code is also simple. Just sort the array, then compare the first and last strings character by character until you find a mismatch or reach the end. The time complexity is O(n) log n multiply L, where n is the number of strings and L is the average string length, since comparing two strings during sorting can take up to L character checks. The space complexity is O1, although Python's built-in sort requires about O(n) additional space internally.